All 8 billion of us are doing metabolism at all times. This show is about learning what metabolism is, how it affects you in every way possible, from mood and mental state to performance and energy. We are all about fine tuning the human experience for you to achieve the best self you can be. And if you are someone who loves science, curious to know how your body works and how to optimize it, then you are in the right place. This is the H.V.M.N. podcast. In this episode, we have Dr. Valter Longo. And Dr. Valter Longo is the Edna M. Jones Professor of Gerontology and Biological Sciences and the Director of Longevity Institute at the University of Southern California, Leonard Davis School of Gerontology, Los Angeles, one of the leading centers for research on aging and age-related disease. Dr. Longo is also the Director of Longevity and Cancer Program at the IFOM Institute of Molecular Oncology in Milan, Italy. In this episode, we covered the differences between fast-mimicking diet and conventional fasting. Why would you pay for a diet when you can simply not eat? We also covered how fast-mimicking diet can be used to counter cancer, diabetes, Alzheimer's, autoimmune disease, among others. He even gave some tips at the end on how to live a long, healthy life. So make sure you stay tuned and enjoy this episode. Thank you for listening. And today we have Dr. Valter Longo here. Thank you very much for coming on to H.V.M.N. podcast. Welcome. I know you just recently gave a keynote speech at the Metabolic Health Summit last weekend. Very kind of you to make time for us.
Oh, thanks for having me.
Yeah, so previously we did record an episode, but it was due to technical issues. So here we are again, and I'm honored to pick your brain about fast mimicking diet, about fasting in general, about all the metabolic differences in therapeutic areas. So before we go on, please let our audience know what your background is and how you came about into this space.
So my background is in aging and longevity, and I've been doing this, since I was a kid, pretty much. Since I was 19 years old in Texas, and a music student, and now I direct the Longevity Institute here at USC and a lab here at USC, and I focus on aging, and I also run a lab at the IFOM Institute in Milan on molecular oncology. So yeah, that's those are my main jobs. Yeah.
What are the most exciting research that you're doing right now?
A lot of research, and I think we're very excited about our cancer work because the idea is to use the this what we call differential stress resistance and differential stress sensitization to treat cancer. And then a couple of years ago, we discovered that if you use fasting mimicking diet, we can put cancer cells into a corner and they rewire. And when they rewire, they desperately depend on certain pathways, which can easily be drugged, meaning that you can use drugs to target them, right? So now we have a system where we do RNA-seq, so we look at the RNA, we look how the cell responds, and then we quickly can tell which escape they're using, right? And so we're very excited about that because I think it could really be an opportunity to go after most cancers, with a combination of drugs that are very effective against a particular target plus the fasting mimicking diet. So that's one, and
Yeah, go ahead. That's one,
and then we're very 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 excited about this reprogramming this Yamanaka factor and the role of the fasting mimicking diet in turning on in different organs different Yamanaka factors.
And what does Yamanaka factors do?
So Yamanaka factors are these pluripotency genes that are turned on to turn a somatic cell, so a cell that has a specialized job, into an embryonic like stem cell, right? And so Yamanaka got the Nobel Prize a number of years ago, together with Sir Gurdon, for stem cell work and for discovering these factors that turn on differentiated cells, that turn on indifferentiated cells to make embryonic cells. Now, when that happens, one of the things you can get, or you do get, is the rejuvenation. So not only you're going from a cell to a embryonic cell, but then you can potentially go back to that differentiated cell, but now it's a brand new cell, right? It's a young cell. And yeah, so then that's we're applying that. We first started many years ago, 10 years ago, with the blood, and then we moved to the gut, the brain. Now soon we're going to publish on the kidney. Yeah, so it seems like to be working everywhere in the mouse, in the rat. Now we're showing, and now we're starting to show evidence from clinical human trials that this is probably occurring. Although it's much harder to demonstrate. I mean, it's easy to see evidence for it, but it's hard to demonstrate that that's what's happening.
Right, right. And this is essentially reversal, right? Instead of looking at from a therapeutic point of view, this is like almost age reversal. Is that correct?
Yes, I mean, it's a lot of people that talk about it make it sound easy and like tomorrow we're all going to be 20. But yeah, so you can reverse, you can take a cell and you can make it young. But and now we're showing that, for example, some years ago, 7 years ago, we published on the pancreas. So we take a toxin, we damage irreversibly the pancreas, so the pancreas of mice does not make insulin anymore, and that's a permanent damage. Then we start the fasting mimicking diet, and we show this Yamanaka factor turned on, and then the reprogramming happens, and then the cells they start making insulin again, right? So both in type 2 diabetes and in type 1 diabetes.
And
Yeah,
you're
so
absolutely, yeah. So go ahead.
no, so I just suggest that it can be used to reverse the
Yeah.
permanent damage. Now, did we make the pancreas young? Well, probably not young, but younger for sure, right?
And we don't know the sustainability either.
We're not as sustainable because it's long term. Then we monitor long term, right? So long term, they're months later they're still making insulin normally, right? So this was not a temporary solution. And in fact, in the mice, in the hematopoietic system, we did double transplants, right? So we did the fasting mimicking diet, then we took the bone marrow, we transplanted the mice, we irradiated the mice, transplanted it, then the bone marrow, the hematopoietic stem cells expand, and they give rise to a say new immune system. And then we did it again, right? Then we did a double, what's called a double transplant. So that means that these effects on stem cells are very solid, and they can lead into very long term effects.
Right. And I just want to comment, you're absolutely right. When you can show reprogramming, and for people who are who have not, done cell research, it's much easier to reprogram cells on a petri dish versus having that effect replicated in a live animal or a live human, because we have to take into account the interaction, the signaling between the cells within the organ itself, let alone within the system, because there are all sorts of signals that are being sent at all times to really maintain the check and balance within the body. So as we know, even in senescent cells, why some cells senesce and then they start secreting these signals around them, and the other cells senesce and have programmed cell death or apoptosis. It's because they're all connected in one way or another.
Right. Yeah. And then the ultimate challenge, of course, is non-dividing tissues, the heart, the brain. So how do you do that there, right? Where these are non-dividing, especially the nervous system has the stored the memory. And yeah, so that's going to be interesting and very, very difficult to navigate. But I think that's what makes the next 30 years very exciting for a lot of scientists.
Yeah. So before we go on as well, could you just briefly explain to us what is a fast mimicking diet and how is that different to just conventional fasting?
A high fat, low calorie diet that lasts from 4 to 7 days, depending on what we're trying to achieve with it. It started as a 4-day version many years ago, I think in 2009, when we tried to we were running a clinical trial on patients with cancer, and we realized that they did not want to do water only fasting, and the oncologists were not comfortable with that either. And also, we always thought the FDA eventually is gonna not even gonna allow any of this to go forward. And yeah, so it was very important to standardize it, to allow people to patients to eat, to make it safe. So now that the salts are in there, and the nutrients are in there, so we're trying to achieve the fasting response without the malnourishment or the temporary malnourishment that comes with fasting. And that was probably a very good idea.
And how much calories is that per day?
Yeah, it changes. For cancer patient, it's about 600 calories per day. For normal people, it's 800 to 1100. For Alzheimer, it's about 1400. Yeah, so it just depends what we're trying to achieve.
So the difference in calories, does that dictate the the significance in the fasting effect, or why the difference in calories?
Well, I mean, you have two components, and one
Hmm.
is the caloric restriction, right? And two is the fasting mimicking property. So
Correct.
if you so part of the effect you get from the restriction, and part of the effect you get from the fasting mimicking property. So then what we do is we have enough of a restriction plus the fasting mimicking property to give a full fasting response, right? So then that's why it's a high fat, and there's glycerol in there, and there's all kinds of components that are trying to be consistent with a fasting response. So in a fasting organism, glycerol is elevated, and fat is part of the fasting response. Sugars and proteins and especially certain amino acids, are not, or many amino acids are not. Some amino acids, maybe they come from the muscle, but and from amino acids, but others are down and lower. So yeah, so we're trying to achieve all of these effects so that the patient gets a full fasting response, but they can eat a reasonable amount of calories.
I see. Um, and you literally just explained this from a scientific point of view, but I would like to ask you to explain it from a non-scientific point of view, because a lot of people ask this question, right? If I am fasting and I have a snack of, say, 100, 200 calories, would that break my fast?
If it's a fasting mimicking snack, no. If it's a regular snack, almost for sure, yes.
And how does one differentiate? How does one know what kind of snack it is? Like, how do you define fast mimicking a snack?
I mean, our standard is a clinical trial, right? So
Hmm.
that's what we did. For example, we have a fasting, or I shouldn't say we, the company that founded many years ago has a bar, right? That is being designed and developed for the purpose of not interfering with the fasting response. And so they did a trial where they give patients a regular breakfast, or a regular snack, or the fasting mimicking snack, and then look at glucose and look at ketone bodies and look at how those are affected. And so if you're not lowering the ketone bodies and not increasing the sugars, then then you probably got achieved the fasting response. Now you can
Yeah.
go more in depth, look at IGF-1, IGF-PP1, and etc. So you can go further, but the ketone bodies and the sugars are both maintained at the fasting level. That's a
Yeah.
pretty good sign. Yeah.
Yeah, no, thank you very much for the explanation. So essentially, I think now that we know more about human metabolism, the human body, and the effect uh, that fasting has on our bodies, we can now differentiate between foods that are going to break fast and foods that are not, based on the properties and the effect it has on the body, rather than just counting the calories, right? Most of the time, people are like, oh, I'm having a sip of sugar water, it has maybe 50 calories, but it's not going to break fast because fast mimicking diet has like hundreds of calories. But then if you are taking in sugar, you're also raising insulin, and insulin will inhibit most of the effect that you want to try to get from fasting. So that sort of knowledge is important, to modify how you fast and what sort of things that you may or may not consume when you're fasting. So your work around therapeutic areas are super interesting, right? Because we are essentially using nutrition to battle all these different diseases that are the main killers of the world, that have only been treated with pharmaceuticals and drugs. So tell us a little bit more about, let's focus on cancer first, because you started with that. How does fast mimicking diet help with cancer, in conjunction with the drugs that they use? Like what do we know, what mechanism of action at the moment of fast mimicking diet that's helping?
Yeah, so the mechanism is what I mentioned earlier, right? So in the old days, when we first started this like 20 years ago, we were thinking fasting and fasting mimicking diet cycles, so that we don't get too much weight loss, and that's it. Then we added the chemo, then we had a lot of things, and now I think we're excited about two things. One is what I said earlier: push the cancer to an escape modality, and then target those with whatever FDA approved drugs there are, right? So if it's TOR, targeted with rapamycin. If it is PI3 kinase, pictilisib. If it's CDK4/6, palbociclib or ribociclib. So that's very exciting, and I think that we're helping lots of now hospitals begin to think about clinical trials. And then the other one is non-toxic intervention. So some years ago, we published on vitamin C plus fasting mimicking diet. So we're very excited about that, because now, unlike what I just mentioned, is it possible to turn cancer treatment into like antibiotics treatment? We're like, oh, you may have cancer, why don't you take these three things? And it sounds like science fiction now, but very close, right? Very close, right? So then why is that? Well, if it's non-toxic, right? If it's vitamin C and a fasting mimicking diet, they're both anti-aging, right? So now we're saying, well, what if we expand this? And that's what we're going after, and we'll see. But yeah, so it's an interesting possibility on the cancer side, that you could have a non-toxic cocktail that now can treat cancer. I mean,
Right.
of course, we already shown that for colorectal cancer and other cancers, and in mice, so it works very well just with the two drugs. And then if you had the chemo, it worked even better. So it told us, effective chemo then flattened the cancer completely stopped growing. So with the three intervention, right? But so you want to get rid of the chemo and then replace it. And the question is, what do we replace it with, so that we can go after cancer? It's not an easy thing, but now we're getting in within within range, right? Within range, it's like, yeah, maybe this could target a lot of cancers.
Yeah. So that's my next question, because I don't have a lot of expertise in cancers, right? But I do know that different cancers are being treated differently, and they may metabolize differently, and there's a lot of nuance in between them. So how do you differentiate the different fast mimicking diet, or do you think all the fast mimicking diet would work with most cancers, like just a blanketed treatment rather than a tailored specific treatment?
Yeah, I would say I'll have a crazy statement, which is like, I think the fasting mimicking diet works with all cancers, right? But it does not work for any cancer alone, right? Well, one, right? We just published on that, cancer research publication, CLL, right? So we have a couple of patients actually that we've been treating only with the fasting mimicking diet for years, 5 or 6 years, and kept them off drugs. So for some blood cancers, we see fasting mimicking diet alone working, but that's about it, right? The other cases, it slows it down, but then the cancer eventually grows, or even becomes resistant, and then takes over. Or the cancer stem cells become resistant and take over. But in combination, it's a very powerful wild card, right? And why is that so powerful? And this is what I'm always amazed that it's been so ignored in the cancer field. You know, say people are so obsessed with what's different between cancers, they're failing to see what's always the same, right? And what is always the same? Well, the hallmarks of cancer, right? So, for example, the cancer rebels against starvation orders, right? Or cell cycle orders to stop dividing, right? That's a feature of cancer. I refuse to stop. Well, that's all cancers, right? To some level, some completely refuse, some partially refuse. But no matter what, that gives you an opportunity to use the starvation condition, and now all the normal cells know exactly what to do. No normal cell is going to continue. I don't care that I haven't eaten for 5 days, I'm going to keep on going. It doesn't happen like that. Why? 3 billion years of research and development, right? So this is started billions of years ago. So from bacteria, they respond to starvation, yeast respond to starvation, and human cells and human beings respond to starvation. And so yeah, so then all the normal cells go in one direction, and all the cancer cells go in whatever direction they want to go, right? So there's an incredible opportunity now to say, yeah, what do I target? What allows them to do that, right? It's something that is very different from the normal cell, and that's what we go after. We go after this rebel pathway. This is rebel escape pathways, and so theoretically you can use it for any cancer. Now, for the ones so far, it looks like it's between 2 and 3 pathways, right? 2 and 3 pathways. And that's remarkable because, you think maybe it's 200. No, it seems like in most cancers we looked at is between 2 and 3 escapers, right? So, for example, for hormone therapy in breast cancer, it was 2 drugs. I mean, we did it the other way around for hormone therapy. So we used the standard of care, estrogen receptor blockade and CDK4/6 blockade. So this is 2 drugs, fulvestrant and palbociclib. So we started with the drugs, and then we used the fasting mimicking diet, and the tumor started regressing. This is in mice, of course, right? Although we also tested it in people. And so you can turn around and say, what if I use the fasting mimicking diet? So a fasting mimicking diet lowered IGF-1, insulin, and leptin, right? And all 3 were necessary together with the 2 drugs. So then the 2 drugs represent the blocker of the escape pathways, even though in this case we did it the other way around.
I get to interview all these doctors, scientists, and cool people in this health and fitness industry, all made possible because of this podcast that is funded by the company I work for, which is Health via Modern Nutrition, or H.V.M.N. And it is not that they pay me to do this, but I genuinely love and believe in the product Ketone-IQ. I use it every day before my podcast, before my workout, or even after my workout for recovery. There hasn't been a single supplement that can give me such a drastic change in subjective feel within minutes as much as Ketone-IQ has. For those of you who do not know me, I'm from Malaysia, I got my PhD from the UK, and my passion is in science and chronic diseases, and I believe it is all about transparency, scientific integrity, and about sharing with everyone so that everyone can benefit from it. And if you like this content and our work, please do support us by liking, leaving a review, or sharing with your friends and families, or even buying a shot of Ketone-IQ at any Sprouts nationwide in the US, and the first shot is on us. Just scan the QR code and you'll get your money back for your first shot. You can also use the code H.V.M.N.POD20, that is H.V.M.N.POD20, and get 20% off your first purchase at the H.V.M.N. website.
With the drugs to then, do the kill the cancer with the FMD. Now we're starting with the FMD and we're looking for the drugs. And so in another paper with triple negative breast cancer, we showed that it was PI3 kinase, TOR, and PI3 kinase, TOR, and CDK4/6. Those were some of the key escape pathways that they were important. Yeah. So anyway, so that now it's a question of quickly identifying the escape and then having drugs that target it. And if it's true that most cancers have 2, 3, 4 maximum escape pathways, then it's a scenario that could be used for all cancers.
Now, you mentioned earlier about the Yamanaka factor, right? Would that be affected in the cancer cells when you have FMD?
Sometimes they are, right? Yeah, sometimes they are. Sometimes they go down and sometimes they go up, right? And some cancers, stem cells, may have high levels of MYC, for example. And some of them, after the fasting, may have low levels of MYC. So, yeah, it can go. So, the Yamanaka factor can become part of an escape. But
That's why you use it in conjunction with the drugs.
Yeah. So the question, I mean, the job is to block all the ability to grow, and and so in a lot of the cases that to grow they have to make DNA, they have to make amino acids, et cetera, et cetera. So you're just blocking their ability to their building blocks, let's say, uh, in addition to the energy, the ATP, right? So they need energy, but they also need building blocks, and you just got to take that away. And it looks like it's between 2 or 3 escape pathways in most cancers. Yeah.
What do you think is the specific role of ketones in fast mimicking diet in treating cancer?
Yeah, so a lot of cancers seem to be sensitive to the ketones, right? So some cancers like the ketones, but it seems to be a minority. So the most of the cancers seem to not like it, and that may be one of the ways that the ketones are killing the cancer cells. And there's a number of papers now that have shown that. And yeah, and also the ketones may be signaling to the immune system to kill the cancer cells, right? So yeah, those are two things that I've seen lots of groups starting to publish on, and so I think both are interesting. Direct effects and indirect effects of the ketone bodies on cancer attack.
Yeah, I think the signaling effect of ketones are really, really interesting, but it's also really difficult to really pinpoint unless you know roughly where the pathway you're going, and trying to figure out what it does. Whereas the direct effects are much easier to measure, right?
Yeah.
All right, so let's move on to Alzheimer's, because I know you mentioned Alzheimer's as well earlier. How does this diet help with Alzheimer's, which has a very completely different disease progression and mechanism of action compared to cancer?
Yeah, so for Alzheimer, we published a paper in 2 different Alzheimer models in last year, and it worked very well in delaying cognitive decline, in reducing beta amyloid and tau, but the main thing, the very powerful effect that we saw is this anti-inflammatory, neuroinflammatory effect. And it really, also when we did the omics, so we looked at gene expression, hippocampus-wide gene expression. It's very clear. A lot of the many inflammatory markers were downregulated, and so in a very strong way, right? So then that's what we think may be powerful about the FMD cycles. And then we also saw regenerative, like stem cell effects, but it's not clear, is there enough to make a difference? The anti-inflammatory effects were drastic. The effects on stem cells are significant, but not clear whether they can do anything. And then we finished a clinical trial, on 60 patients, and we were surprised that they were able to finish it, right? Because to tell you the truth, I thought this is going to be a very few people be able to finish this, like once a month for 12 months, FMD. But yeah, I think maybe 70% or so of the patient were able to finish, and we'll see. We have to analyze the data. We'll see what it looks like. But I think what's exciting about by the time, if you talk to neurologists, by the time somebody's got Alzheimer's, they'll say, it's it's going to be tough to do anything about it. The brain is so damaged that. But the exciting part is combination with lots of drugs and therapy, and that's going to be interesting at some point, FMD plus plus, like for cancer. But I also started thinking about earlier, like what about somebody that gets a PET scan now, and they can tell you, hey, maybe in 20 years you're going to develop Alzheimer, right? And now we know that diabetes is it almost doubles the risk for Alzheimer, and yeah, so then. Could this be a way to, instead of getting Alzheimer at 80, you get it at 87, and maybe by then you're gonna die of natural causes, right? So yeah, so I think that that's an exciting, very realistic part. Now reversing Alzheimer's is much harder.
Exactly. Exactly. I think there's a lot of work that's being done right now. I think in the NIH as well, using exogenous ketones and Alzheimer's and dementia, just looking the specific effects of ketones and the brain and how it has profound acute effect on both the brain energetics as well as the interactions between brain regions. It's really, really fascinating.
Yeah, and by the way, we in the trial we gave ketogenic components every day between the FMD cycles, right? So
Wow.
the 300 extra calories came from 300 or 400, I forgot, from ketogenic food. So we gave them the FMD for 5 days, and then because we were worried about muscle loss, we give
Right.
them ketogenic ingredients to supplement their diet
Yep.
for the 25 in between days, right? So it worked pretty well, right? So
Yep.
so yeah, so I
And
think
that and that's
we were
smart.
trying to go with all the weapons that we have.
Yeah, no, and that's smart because ketones have been shown to mitigate muscle wasting in cancers. That has been published. So we know ketone to a certain effect does preserve muscle mass to a certain extent. Obviously, if you are still continuously being malnourished, then you will lose some muscle mass, but at least that sort of effort will be able to keep your muscle on for longer.
Yeah.
Diabetes. You mentioned diabetes. That's a great area. It's last time I wrote my PhD thesis was like almost 10 years ago. That was, I think, 500 million people was affected by diabetes in the world. I think the number really jumped up now. I haven't looked into
540.
540. Okay.
That's the last
Another
I
40
see.
40 million people in a few
That's
years.
yeah, yeah.
So 540 million people affected by diabetes. How can fasting or fast mimicking diet help with diabetes?
Well, for diabetes, we have the most, by far, the most conclusive results, right? Way more than cancer. I mean, cancer is a lot of cancer, a lot of therapy. It's very, very difficult. It's going to be very difficult to move into the standard of care. But we're trying, but it's a long, long, difficult try. For diabetes, this is trial number 4 is about to be published by University of Leiden with 100 patients, 12 cycles. Heidelberg published a couple of years ago, and the results are really remarkable. So 50 to 70%. So the the Heidelberg trial, diabetes patient receiving 6 consecutive cycles of the fasting mimicking diet, and the in the Leiden trial is diabetes patient receiving 12 consecutive cycles of the fasting mimicking diet.
When you say cycle, is it once a month?
Yeah, once a month cycles. Yeah, yeah. With the idea eventually to make it a lot less frequent, like every 2 months and year 2, or maybe even every 3 months and year 2, right?
Got it.
So it's like suffer a little bit, and then and so 50 to 70% of patients reduce drug use, right? So and so reduction of A1C plus 50 to 70% reduction in drug use in both trials. In the Heidelberg trial, A1C dropped from 8.1 to 6.7 on average, right? Which is really remarkable effects comparable to very strong drugs. And so, yeah, between the 2 pre-diabetes trials and now the 2 diabetes trial, we're getting pretty close to conclusive evidence that without changing lifestyle, without taking drugs, actually lowering drug use and maybe 15% becoming going into remission within a year, the FMD can be very effective, right? And so, yeah, so I think that now it's a question of looking around the 500, talking to the 540 million people, and say which one of you want to stay on drugs for the rest of your life, and which one of you instead would rather give it a shot without revolutionizing your lifestyle or reversing this diabetes, and yeah, so I think that I'm very excited about that, right? And because you use Ozempic and all these drugs, and great. I mean, a lot of people need the drugs. They just can't change anything. It cannot even do the fasting mimicking diet. Fine, but that's it, right? That should be the standard, right? You do the drugs only when not only you cannot change your lifestyle completely, because of course most people can't. Let's say 90% of people are not going to be able to change their lifestyle long term, or so. But I think you should get drugs only when the periodic use of the diet fails, right? Or you cannot do it. It's like, I tried, I get to day 2, I drop it. Okay, that's fine then. But even then, I think, and I know that it sounds crazy to most people, but even then, I think it should be now fasting mimicking diet plus the drug, the Ozempics of the world, just enough so then you go back into regression and remission, and then you drop the drug, right? So because the hunger, and this is what we have some endocrinologists in Brazil that are doing this now with the GLP-1. So they're using the GLP-1 agonist to make you less hungry, so you can do the FMD, right? And then
I see.
and then they reverse that, and then they say they drop the drug, and that's it, and you're cured essentially, right? That's I think we're very excited about this possibility of not using drugs, or using this maybe not, maybe there's some of the shorter lasting GLP-1 targeting drugs that could be compatible with the fasting mimicking diet.
Yeah, this is super smart to use GLP-1 to reduces hunger, control appetite, and use it in conjunction with fast mimicking diet so that people will find it, especially people with insulin resistance. Obviously, they're going to have, if they are having also obesity, they're going to have a much higher demand for calories and food, and for them to go through fast mimicking diet is going to be hell. And this coming from a family with high prevalence of diabetes on my mom's side, like I do know that most people, once they get diabetes, they within those like 540 million people, majority of them probably don't even know that we can now reverse diabetes or reduce usage of drugs, because most of them, when they get diagnosed, they just accept it, especially if they grow up seeing family members already having diabetes and had to deal with it on a daily basis. Then it sort of almost normalizes it for them in their heads, and then when they get it, they're like, well, it's just my rite of passage, which is untrue. So I hope this message reach people out there, even if it's one more person who can share and tell people that nowadays, even though the numbers of people with diabetes are increasing drastically, we can, and there are tools that people can use to reverse it and really increase insulin resistance, insulin sensitivity.
Yeah, and let's not forget the team, right? You gotta have the team, the doctor, the nutrition and dietitian have to be there, and the doctor doesn't have to do a lot of work, and maybe we think just initial explaining, I'm here, let's make sure that you don't get hypoglycemic, make sure that if you're going to mix it with drugs, it's done very carefully, and this can turn ugly, right? If you combine fasting making diet with drugs, especially insulin and insulin releasing drugs, it could turn out. But it was handled by Heidelberg, it was handled by Leiden, so it can be handled, and that's why the doctor should be there handling it, and then the dietitian can do most of and the continuous glucose monitor. I think at the beginning, yeah, why not? Especially if you're going to mix drugs with, I would say there should be a must, like a requirement. If you're going to FMD plus drugs, have a CGM on, make sure that everything looks good, and then eventually, as you reduce, maybe as you eliminate the insulin use, then you stop. Yeah.
Right. Now, from a basic scientist point of view, I have to ask, do we know that fast mimicking diet is directly targeting insulin resistance? When you saw the HbA1c going down from 8.7 to like 6, 8 something to 6 something, is that due to decrease in insulin resistance? Is that due to, you know, improvement in the pancreatic beta cells, or do we know what exactly is it affecting?
Yeah, I mean, in rodents, it's very clear. Insulin resistance is reversed and or reduced, and and insulin usually goes down or way down, right? So most of the FMD clinical trials show a drop in insulin, a drop in glucose, a drop in insulin. So that means that the patients are most likely. Well, actually, Heidelberg did the HOMA IR, and it was huge. And interesting, if you look at that paper by University of Heidelberg, um, they have FMD against 5 days of Mediterranean diet. And I don't know why they picked that, but I'm assuming somebody in the team, maybe not the first author, but somebody in the team said, you know what, yeah, just given the Mediterranean diet, it's going to be the same. It's just a healthy diet. And then you look at insulin resistance, and Mediterranean diet, and the A1C, and Mediterranean diet does absolutely nothing, zero. And then you look at the FMD, and you see HOMA and the A1C collapse, right? So yeah, so definitely, even the clinical data now suggesting reversal of insulin resistance, very clear, and it's not just by giving people a healthy diet.
Right. And you know, having studied diabetes and cardiac metabolism for my PhD, people always ask me, so is it the insulin deficiency that comes first, or the overcompensation that comes first, or is it that insulin resistance that comes first? And from how I see what you just explained, it's pretty much because the fast mimicking diet is lowering insulin, you are essentially decreasing the exposure of your peripheral cells, of your muscle cells, for example, which has a lot of insulin receptors that are initially insulin resistant, but because you're lowering that exposure by lowering insulin secretion in general by using fast mimicking diet, you are now giving time for the muscle cells to recalibrate and decrease insulin resistance or increase insulin sensitivity.
Yeah, sure, but we go much further up, right? In an evolutionary
Yes.
reasoning, and the evolutionary reasoning is like diabetes was never a disease in the first place, right? And diabetes was always there, like it is in the emperor penguins, like it is in a lot of animals, is there to accumulate fat in the period when you have a lot of sugary, like a lot of fruit, a lot of honey. So eat, become insulin resistant, store the fat, because when the winter comes, you're gonna need all of that, right? Yeah, this is very simple, and it's just criminal that the medical community just completely ignores all of this. This is why the FMD works so well, because it's giving you the signal, and it's tricky, right? Because it's not about just fat. People use words fasting, means nothing, right? Why? Because if you go too long, so if you do it for the right amount of time, now you reverse that, and the system says, okay, I was in a fat accumulating mode, in a summer mode, and now I go to the winter mode and I burn the fat. If you go too long, now it gets into a thrifty mode. And what happens, and this was published by Label and other people many years ago in the New England Journal of Medicine, you go into a hypometabolic, low energy expenditure mode, right? So now you go from one problem to the other problem, even worse, right? Because now it's a nightmare. You're burning very little calories, and you're like in a hibernation mode, right? And so you have to unlock it without entering in the hibernation. I mean, it's not a hibernation mode, but I'm calling it that just to make it simple for people, right?
Exactly.
Unlock it, unlock the insulin resistance, but don't get into hibernation modality. And that's where you want to be. And that's why we see patients over and over and over, because we have 2 clinics for the foundation.
That is such a great point, is that insulin resistance has always been there as a mechanism, as a
beneficial, saving your life.
It's exactly. It's a compensatory mechanism to allow us to adapt to our environment back in the day when we didn't have abundance of food, when we didn't have regulation of temperature and all of that. And and now, because the change in environment, we are constantly being fed with the abundance of food and not have to deal with seasons where we run out of food, and hence that is why fasting and fast mimicking diet have such an effect, a profound effect on balancing that signaling within the body in order for the body to reset.
But this is why I would say, let's get rid of the word fasting, right?
Mm,
Because that's why it's failed all these years in the medical community to go anywhere. Because on one side we have the FDA, we have all these regulatory committees, and then on the other side we have words, right? And of course, like I just mentioned, if you go too long, it's going to go into hypermetabolism. You go too short, you're not going to. So I think we gotta stop. And I'm not saying the company I started. It could be lots of companies. I mean, eventually it's gonna be a lot of companies. But let's start standardizing it in a way where food becomes medicine, and then but it is regulated. It is based on trials, and it's very carefully designed, right? So it's not fasting does this. It is a 5-day fasting mimicking diet done for 6 cycles, in the with the doctor, with the dietitian, will achieve these effects in 80% of the people or something like that, right? So yeah, I think it's really, because otherwise we're going to go back to the medical community turns against this, and it just disappears again, and then 50 years on the road it comes back, with the next try, and then disappears again, right? So yeah,
yeah.
I think it's now is the time. I think that this fasting mimicking diet and other dietary intervention are going to be here to stay, and to represent food as medicine as a
Right.
reality, and not just a 2,000-year-old idea.
Yeah, exactly. And from what we just talked about, I think um, it's reasonable for us to think that having food or abundance of food for too long is not good, obviously. But fasting for a prolonged period of time is also not good, because you're sending that constant starvation mode signal to the body as well.
Yeah, and also fasting for a short period, if it's water only, it could definitely be dangerous to a portion of people. Could it be 5%, 10%, 20%, or could it be 80% if you do it enough time, right? So now you have no salts, in no calories, and so you could have hypotension, hypoglycemia, and lots of issues, right? And people say, well, but I've done it and nothing happened. It doesn't matter. You could do it 20 times, nothing happened. The 21st time you're driving on the highway and something does happen, and you're going to be in a lot of trouble, right? And I'm speaking for experience, not my experience, but experience of people that contacted us and said, I thought that I've always done this, but sure enough, maybe it's because you have the flu, maybe because you have the beginning of the flu. And yeah, that's why I think it's very important to standardize it, and think about all these things, so that people don't become hypoglycemic, hypotense, etc.
That's a great point. So, people who are listening and or watching, um, making sure that your body is suitable to do, fasting. And while the benefits are very well elaborated, like Dr. Longo said, some people may face higher risks of, some form of complications if you do too much, water fast and whatnot. And maybe then fast smoking diet could be a good alternative to a traditional water fast. So, for our audience who would like to know more about, all these efforts and research about you, Dr. Longo, where can they find you?
Yeah, I think the createcures.org, the foundation website, Facebook, Professor Valter Longo, in English and a few other languages. Yeah, those are the main. I think Instagram. Um, yeah, so those are probably the three places where.
And Instagram is your name, or is the
Yeah, I think it's
create?
Professor Valter Longo. I don't. I just give them. They ask me for content. I give it to them, and they post it. But I think it's my name. I don't think I've ever been on it, So, but
All right.
yeah. So
Well, before we go though, I do want to ask you for some, say three advice that you could give us for a uh, to live a long and healthy life. What three advice would you give us?
so number one would be do the longevity diet, and I wrote a book about that. So get the book. It's all charity. I don't make a penny out of it.
What's the book called?
The longevity diet.
The Longevity Diet. Got it.
And number two would be fasting mimicking diet at least a couple times a year. And number three would be 150 minutes of exercise plus an hour a day of walking. 150 a week of exercise per week, and plus an hour a day of walking. Yeah, I think if you did those three things, probably have a good chance of living very long. Yeah.
There you go. Thank you so much again for coming on to the H.V.M.N podcast. I definitely learn more and more every time I speak to you. So thank you.
Well, thank you.
And I hope people who are listening and watching also learn as much as I did on just about everything about fasting, fast mimicking diet, just human evolutionary path that led us to where we are today and how our bodies respond to drugs, to food, to different diseases, and why are we the way we are. And I think that really was my driving force when I was a kid to want to be a scientist. It's asking why. Why does my family have diabetes? Why do they end up like that? Why do they have to take drugs? Why and that, this and that? And guess what? 20 years down the road, after my undergrad, I'm still asking those questions, and it just becomes more and more complicated. And the more you learn, the less you feel that you know. So, all right, thank you, and I'll see you soon. Hello to all my listeners and viewers of the H.V.M.N podcast. Unfortunately, I am here to tell you that this will be the last episode of the H.V.M.N podcast. For a while, we are taking a pause as my role at H.V.M.N evolves, and I am going to focus more of my bandwidth and efforts in the research, exciting research I have to add, in exogenous ketones, specifically Ketone-IQ, in heart failure, in sleep apnea, in performance, and all of that. Very, very interesting area of looking at exogenous ketones. So, which also means that I don't have enough bandwidth to keep this podcast going. So that's very unfortunate. But I also want to use this opportunity to really thank you. And I'm really grateful for you to tune in every week. It has been a dream come true because my passion as a scientist is to relay scientific information to non-scientists. And you guys gave me that platform, and you guys actually came in and listened and gave me that opportunity to also improve myself as a communicator, as an interviewer, and most importantly, as a human being that is able to relate to you when it comes to whether it's short form or long form content. So I want to thank you so much. And it's crazy to think that a year and a half ago, that thousands of people would tune in every week and listen to me. I mean, I can't even stand my own voice in the beginning. So this has been an amazing journey. And this is not to say that H.V.M.N podcast will not come back. We're taking a hiatus, and it's just simply a pause. So who knows? We might come back next month, or in half a year and whatnot. And if you think I should start my own podcast, give me some comments on the feedback form and tell me what I should be doing myself. Also, I would like to thank those people who actually go out of your way to leave comments and feedback to help me improve as a podcast host, as a scientist. So thank you so much. And again, this is not farewell forever. And please keep on follow me if you want to know more about me on my Instagram at Latt Mansor, on TikTok also Latt Mansor. So feel free to message me there. I always check my messages and comments and whatnot. And I hope to see you guys on other platforms and speak to you guys. All right. So thank you so much for listening to the H.V.M.N podcast. And this is a wrap for now for 2024. Thank you.